I was going to say welcome back, but you've never been here before. I'm actually on the job site, and I've got a little bit of some spare time here, taking a little break, and decided that I would do a little bit more on the CR30, because in part one, I only got so far and I really didn't get to the good stuff. So in this little session, I'm going to show you a little bit about configuration. So let's get at this. As discussed in part one, you look at the chart here and you see the 22 I/O points plus 24 volts DC and common 0 volts DC. Just to refresh your memory, that typically we expect the first 12 terminals, if this were an LC30, to be inputs, and then the remainder 12 through 21 to be outputs. And you can see 0 through 11, they are inputs. In the case of 10 and 11, they can be safety input normally closed or single wire safety input. Now exactly what that means, we're going to explore all this. But it's the second group, 12 through 21, you can see that the last four are strictly outputs, 18, 19, 20, 21. But 12 through 17 are multi-purpose. They can be SSD high side, or safety input normally closed, or safety input normally open, or standard diagnostic. So let's create a project and take a closer look at that. So I'm going to drag this out of the way, and here's our project. We're going to create new, and we'll just call this test 01. It really doesn't matter what you name it. We just need to create a project because we're going to explore. We go to the safety classification, 440C safety relays, pick the CR30, and of course today the highest rev level for the CR30 is 10, although I have 13 on my laptop. 10 is the highest that's available for the CR30, so nothing changed 11, 12, and 13 for the CR30. So we can select that, add to project. Now you see it's added in over here, and we'll pull this out a little bit so you make sure you're not missing anything. Double click on it, and here's our CR30. Ours has a communications module, 440C eNet, assigned to the first plug-in slot, and then we have digital combo IQ4 OB4 to the second slot. Now you can see it's fully populated. So at this point, we have a hardware configuration that matches the lab station that I'm going to be doing future videos on. So let's jump right into Edit Logic. I'm not hooked up to a CR30 right now, so I can't download, upload, or do any of that. So Edit Logic. What I'm going to do is kind of drift around through this software and point out some things. Typically, everybody has an e-stop. So go over here to Toolbox, over Properties Toolbox, all the way over here to the upper right corner, Toolbox. Now, I already have this square rectangle over here, green. See, I already have it highlighted. So if I just double click on emergency stop, it'll appear there, or I can just take and drag it over and drop it there. Now, here's what I want you to notice. By default, it came up with test source A is terminal 12 and test source B is terminal 13. And if I drag my chart back into view here, you can see 12 and 13 are the multi-purpose I/O. They can be inputs or outputs. Okay, at this point, if you leave it the way it is right now, you have now determined that 12 and 13 are going to be outputs. In other words, they're going to output a safety signal that you're going to use with your e-stop. You're going to go from terminals 12 and 13 through the e-stop switch, two sets of contacts, and then here to input 0 and input 1, but you don't have to do that. So if I were to go look at my choices for the first input, notice that 0 and 1 are grayed out. I've got 2 through 11, and then multi-purpose terminals, which could also be inputs, 12 and 13 are grayed out. But 0, 1, 0 and 1, 12 and 13, they're grayed out because they're already assigned. Now, if I go in here and delete them, then go back over here you see that 12 and 13 are now, can be used there instead. Now, I wouldn't do that. I've never actually tried it. I just wanted to point out that when you drop down to pick, if it's already taken, already assigned, it's not going to let you do it. So let's get rid of 12 and 13 because we have no IO selected now. But what you do notice that although over here, you could pick from 0 through 11 and from 12 through 17 when it comes to the test source, which they have to be outputs. They have to be configured as outputs. So it was 12 and 13 when we did this by default. So I'm going to delete that. And then I'm going to go over here, toolbox, and I'm going to double click on emergency stop. See, it drops it in there. So now we're back to 0 and 1 for inputs, 12 and 13 for our test source. That means that if we save this configuration, we're going to have a signal coming out on 12 and 13 that get fed through the dual normally closed contacts of the e-stop switch. You don't have to use two. You could make it a single wire. Something looks kind of like that. Go to advanced settings and we'll say inputs one normally closed. Okay, see how that tidies that up? Now you've got input 0 and your test source is 12, but you can use 12, 13, 14, 15, 16, or 17. The software by default is going to assign the lowest unused terminal or IO point. So here we have a single wire safety monitoring, but when we started this, we had 2 wire. I just deleted what I didn't want. The big thing I did was change the inputs to one normally closed. And I could also do OSSD. That would be a different kind of device. We'll throw that in there. And now we're going to have OSSD instead of the standard. Let's go back and change that to 2 normally closed, which is what we expect. Pulse testing, we can disable it, meaning that we're not using 12 and 13 to pulse test the emergency stop switches. If I go back to 2 sources, now say I'm back to 12 and 13 here, or it can be 12 through 12, 13, 14, 15, 16, 17. What's nice about this software is as you select things, like right now, inputs 0 and 1, they're used up. 12 and 13, they are assigned as pulse testing. See down here we have pulse testing, 2 sources. Discrepancy time, that's in 50 millisecond units, so that would be 100 milliseconds. Right now it's set to 2 times 50, 100 milliseconds. That's a tenth of a second. And what that means is that the 2 contacts on this emergency stop switch, when you reset, in other words, if you trip it, it e-stops. When you pull it back out, if they don't come back into the same state within the discrepancy time, then it declares a fault, because it thinks you're trying to outsmart it by doing a tie down or some other jump ring to try to get around the safety. Now over here for safety output, and notice when I pick safety output, well, we'll pick here first. Then go over here to toolbox, see it's up here at the top. If I pick this one, then go to toolbox, see we're down in safety output function blocks. The most common is immediate off, so I can drag this over there, or I could have just double clicked. What I'm looking at is terminals 18 and 19 are going to be my safety outputs. Feedback is none and reset is manual, but we can do a auto, which means it will automatically reset itself if you clear the e-stop buttons. So if we set this to auto, you trip the e-stop, the 2 contacts coming into input 0 and 1, and when you pull it back out, it auto resets. So I'll leave that manual the way it was. And with manual, then I have to have a reset input, and I don't have any. And that is because I don't have any over here. So let's look at feedback. I have none because I'm not set up any reset or feedback. So let's go over here to this square and let's do a reset. Okay, and we got that to input 2. It doesn't have to be input 2. Notice I've got something going on here. Notice up here that it was 0 through 11 and 12 through 17, but when I go down here, I also have the 4 inputs from the IQ4, plus I have communication inputs. So I can do this over Ethernet by way of communications during the reset. But we'll just leave it the way it is. No, let's pick the plug-in module. So P2, that means slot 2. Remember, that's a 4-in, 4-out module in plug-in 2. That's going to be a reset. Now when I go here to reset input, I have something to pick. See, this is labeled safety function 2. So we'll pick that. So it's manual reset, and it's looking for this input right here. So you have to have a reset button connected up to this input on that plug-in module. Feedback, there'll be nothing there because we've not assigned anything. But if I go to this green square over here, go to my toolbox, I can go down to feedback monitoring. Okay, and I could have up to 4 inputs. We're not going to do that. We'll leave it at 1. Go to advanced settings, and we can put a filter in 25 millisecond units. That if I set this to 1, then it's going to ignore any state changes that are less than 25 milliseconds. I'm not going to put any filter on it. I typically, it goes up to 40, 0 through 40, but I still want an input, so it's going to be input 2. If you're wondering, well, what can we use for that input? There's embedded safety inputs, 0 through 11. There's multi-purpose, 12 through 17. And then there's the IQ4, OB4. We've already used 0, so we'll pick 1 as our feedback input. Now when we go over here, feedback, notice this is SMF3. And there it is right there. This isn't finished. We have to connect the output from this logic on the front end, the input, over to, and notice that I didn't have to select logic level A and logic level B as pass-through. So the way this configuration is set up is that these are your inputs right here. So you could say that this is your input data table, these tag names right here, and this is some safety logic with those inputs. This is intermediate logic level A and B. And then the output, in this case, we're going to embedded output 18 and 19, and that's what we're going to use for to shut down the system. That's going to be our safety outputs. Notice we can also do some multi-purpose terminals as well. We'll just leave it simple right now. Notice that what I did was I dropped down the list to see what I could use. I can use multi-purpose terminals. So if we drag this over again, you see we can use, it's hard to keep them both up on here at the same time. I don't know if I can do that. No, I can't. But you can see that 0 through 11 are strictly safety inputs, 12 through 17 are multi-purpose inputs or outputs, and then 18 through 21 are strictly outputs. So if we go back here and select again, see we can pick any of the multi-purpose or the actual embedded outputs. Or we could pick outputs from that combo module, IQ4, OB4. So the name of the game here, folks, is to do some exploring. Always keep in mind that 12 through 17 are multi-purpose, so they are the most versatile I/O that you have. So if you strictly need a safety input or you need a specific type of output, don't use 12 through 17 for those. Save those for special needs that come up. Well, we'll try to do another video here in the next couple of days and get it posted as well to just keep moving on this CR30 discussion. So thank you for watching.